So we were investigating a car crash at a stoplight on Tequila Road where an SUV rear ends the back of a stationary wagon. So based on the conditions we have initially, we can find the speed of the SUV immediately following the collision. So we know that the SUV travels 2 meters after the collision at an acceleration of negative 2 meters per second squared, and since it stops, the final velocity is 0 meters per second. So we plug that into the equation, v squared equals v naught squared plus 2a change in x, and we find out that the initial velocity immediately after the collision for the SUV is 2.828 meters per second.
Considering the wagon that was also involved in the collision, the wagon was stationary prior to the collision, so we know that its initial velocity would be 0 meters a second. And then based on the skid marks that were found on the scene of the crash, we saw that the wagon traveled 24 meters after the collision. And with the brakes locked, we knew that the acceleration of the wagon was negative 3 meters a second squared. So using the same equation, v squared equals v naught squared plus 2a delta x, we could plug those numbers in and find that the wagon was traveling at a speed of 12 meters a second after the collision.
With those two numbers, we can find the speed of the SUV before the collision. And we use the momentum equation, where before the collision, the momentum is equal to the momentum after the collision, because momentum is conserved in this situation. So we plugged in our numbers based on the conditions that the mass of the SUV was 3,000 kilograms, and the mass of the wagon was 2,000 kilograms, and plus the speeds we found earlier. We put them into the equation and found out that the speed of the SUV before the collision was 10.828 meters per second.
So looking at the force time graph of the wagon, we can see that the curve is above the x-axis, because when the wagon is stationary and then the SUV collides with it, the wagon is gaining momentum that it didn't have before the collision.
For the force time graph of the SUV, the curve will be below the x-axis because the SUV is losing momentum, meaning the change in momentum is negative.
Looking at the force time graph for the system, you can see that the curve is directly on the x-axis, because as a system, there's no difference in the momentum before the collision and the momentum after the collision. The momentum throughout the system is conserved the entire time.
So if we look at the energy bar graph for the wagon, we see that it doesn't have kinetic energy because it was stationary at the start, and it doesn't have potential energy because it doesn't have a height. So the only thing that causes it to have kinetic energy after the collision would be the work non-conserved, which is due to the collision.
Looking at the energy bar graph for the SUV, it also does not have potential energy because it doesn't have a height, but it has kinetic energy because it's in motion prior to the collision. And then after the collision, some of the kinetic energy is lost due to work non-conserved. This would be friction and the collision itself. And then it has some kinetic energy left over after the collision.
And for the system, you can see that the kinetic energies before and after the collision are not equal because the kinetic energy is not conserved in this situation. The kinetic energy is greater due to the SUV traveling at a speed and the stationary wagon wasn't moving. But as a result of the collision, the SUV loses kinetic energy and the wagon gains, but it's not the same. And as a result, we found out that the type of collision for this situation is inelastic. However, not perfectly inelastic because the objects do not stick together. And we found this out by plugging in our numbers into the kinetic energy equation and setting them equal to each other from before and after the collision. And we found that the kinetic energy before the collision is greater than the kinetic energy after the collision.
Considering the traffic laws broken in this incident, the speed listed on the Tequila Road was 35 kilometers an hour. Now, based on the numbers that we had crunched, we figured out that the driver of the SUV was traveling at 10.828 meters a second before the impact. Now, by either converting kilometers an hour to meters a second or converting the driver's speed in meters a second to kilometers an hour, we determined that the driver was speeding by 4 kilometers an hour. So the driver of the SUV will be guilty of driving over the speed limit and failure to stop at a traffic light.